Okay, as I was rummaging, I came across this and this. And I realized I have not played guitar in over 15 years. So then I got to thinking, why don't I build a 4-string guitar and a very low watt amp and put it on video and explain to everybody how I'm going about doing it. Okay, I'm going to break these videos down into multiple parts. And this first part is just going to be a beginner's lesson. Alright, I'm going to explain how we're going to take this and get sound out of this. Okay, I'm going to try to explain this the easiest way I can where even the most amateur of hobbyists can understand. The first thing we're going to do is a brief history lesson. Okay, about the early 19th century, that would be 1800s, there was this Danish guy by the name of Hans Christian Ørsted who went into his local Radio Shack and he got him a 3-in-1 science fair kit. Alright, this kit contained a battery, a copper wire, and a compass. And he connected them all together. He connected the battery to the wire, and he noticed that it affected the compass. So he went and wrote an article, probably in his latest popular electronics magazine. In comes this OG from the old country. That would be jolly old England to you millennials. This was his gang sign. Went by the name Michael Faraday. Michael Faraday was self-educated. He didn't have any fancy paperwork that you would call a diploma. But he went and read that popular science article. It started running experiments himself, and he actually figured out and understood the relationship between electricity and magnets. Alright, and he went and published his work. A lot of people turned their nose up to him, or they just didn't understand what he was doing. Well, later comes this egghead from Scotland, went by the name James Maxwell. Alright, James Maxwell took Faraday's work and he put these real complicated mathematical symbols beside Faraday's work, and then the whole scientific world went, Eureka, we understand. And that's how we have modern electronics. Alright, I am hoping that everyone understands that sound is a vibration and it is a wave. This is a speaker. The speaker moves this cardboard back and forth, and what it's doing is creating vibration, creating a wave that comes out that you can hear. Alright, if you can remember when you were in school, or for you kids still in school, you'll probably do this experiment. You can take a copper wire and run it around a piece of iron, and then connect that wire to a battery, and then it turns into an electromagnet, and you'll probably go around picking up paper clips. Well, this is a guitar pickup. It works similar, but it's actually backwards. This is a magnet, and inside here is a coil of copper wire wrapped around and around and around. And this is a ferrous material, which is a fancy word for iron. And you need material that is magnetic. Alright, and what happens is you take the guitar string, and as you pluck it, it vibrates and sweeps across these little ferrous material here. And it's going to do the exact opposite as making an electromagnet. What's going to happen is you're going to take this magnet, and out these wires is going to come electricity. And I will show you on the multimeter. Okay, now I got my multimeter set to AC voltage, and I'm going to swipe this piece of iron across the pickup and watch the voltage as it rises. Alright, now I'm going to set it to DC voltage, and if you watch it, it will go positive and negative voltage back and forth. let me explain to you what's going on. And we have this line here. This is 0 volts. This is positive volts, and this is negative volts. Alright, so we're creating an AC current. So what's happening is, as I sweep the piece of iron across that pickup, it is affecting the field. So you're going to get part of it that is positive, and then it's going to come down, and part of it's negative, and then it's going to go positive, and then it's going to go negative. And this is AC. An easy way to understand this is kind of like breathing. You breathe in, you breathe out. This is breathing out, this is breathing in. It's still air and it's pressure, but it's going back and forth. Alright, so as you sweep your piece of iron, actually your guitar string is going to vibrate across your pickup. Right here, as it vibrates across this part right here, it's going to create a wave, an electric wave, and it's going to go up and down this frequency, and that is the actual sound, but it's being converted into electricity. Okay, a speaker works the same way. Going to cut the meter on to AC voltage, and I'm going to take this cardboard part here, the cone, and I'm going to tap on it, and you can see the voltage go up and stop, and it goes back down. Tap on it again, voltage goes up. Alright, what's going on here is we have a bunch of junk connected to the magnet, but we have a magnet here, and then there's also copper coil wire wrapped inside. And as the electricity goes in here, it charges it, and it causes the cone to actually move up and down. Alright, now I got it flipped around to our DC, and if you look, I press the cone in, we're getting negative voltage. Alright, now I'm going to come from the other side, and I'm going to press the other direction, and we're getting positive voltage. Well, negative there, but positive voltage as I press up. Okay, let me give you a different demonstration. I got a different speaker here, and I'm hooking up DC voltage to it, and as I give it power, you'll see the cone come out. Alright, and I'm going to reverse the polarity to it, and we should see the cone go in. And that's positive and negative voltage on the speaker. So what's going on with this? Alright, the negative voltage, this part of it, is making this diaphragm go down, and the positive voltage is making it go up, as it creates vibration, and it's disturbing the air, and that's how sound works. Alright, but as you noticed on the pickup, the voltage we were getting out of the multimeter was very low voltage. So that's going to be very small vibration out of this speaker, and it's not going to be enough to create audible sound for us to hear. So what we're going to have to do is we're going to take that electric signal, and we're going to run it through a transistor. Alright, this is going to be our input, and this is going to be our output. This is our ground. So we're going to have our sound wave is going to come through this side of our transistor, and it's going to come out this side. And what this is going to be the amplifier I'm going to design. And as it comes out this side right here, it connects to the speaker. You're going to take this small wave here, and it's going to increase it to a large wave. It's going to take this and it's going to amplify it. For instance, the word amplifier. And then once you do that, you're going to create more dramatic movement out of this speaker. and it'll create audible sound in which we can hear. So I hope everybody understands that. My next video on this, I'm probably going to start working on the actual amplifier itself, and we're getting into some more technical stuff. And if this week it bored you, hopefully next week you'll be entertained. And if you like this video, give me the Faraday's gang sign and subscribe to see the other videos to this. And y'all have a good weekend.